Hi, I'm Ms. Cho, and in this video, we'll find the least common multiple of polynomials. This is useful for when you're adding and subtracting rational expressions with different denominators and when you're trying to solve rational equations. Let's start by reviewing how we find least common multiple of numbers. Let's say if I were adding two fractions that had a denominator of one with a denominator of 12 and one with a denominator of 20. In order to do that, I would need to find some common denominator which is the least common multiple of both 12 and 20. Well, in order to do that, I'm going to factor both. So I can write 12 as 3 times 4 and 20 as 5 times 4. Once I have that, I'm going to multiply all my factors. I start with the ones I have in common. I see that both share a 4, so I'm going to write the 4 and cross it off. And then I multiply by anything else that's left over. So I see that the 3 is a factor and then 5 is a factor. So my least common multiple is going to be 4 times 3 times 5 or 60. And we know this is true because I can multiply 5 by 12 to get 60, and I can multiply 3 by 20 to get 60. That would give me a least common denominator of 60, and then I can add my fractions from there. Let's take a look at what this looks like with polynomials. In our first example, we're asked to find the least common multiple of x squared minus 4 over n x squared minus 5x plus 6. In order to do that, we're going to do the same two steps. We factor each polynomial completely, and we multiply all the factors, starting with the common ones and then any left over. What we mean by factoring completely is that you can't factor anymore. I notice that my binomial is a difference of squares, so I'm looking for something that squares to x, so that's x, and then something I square to get 4 is 2. And because this is a difference of squares, one is going to be positive and one is going to be negative. In my trinomial, I'm looking for a number that multiplies to 1 times 6 and then adds to negative 5. So that's going to be negative 2 and negative 3. From here, I list all my common factors. I see that x minus 2 is common, so I'm going to check that off. And then I multiply by any leftover factors. I have an x plus 2 and then an x minus 3. So this means my LCM is the product of all 3 of these factors, but you don't have to multiply it out. You can just leave it in factored form. Let's try a second example. In our second example, we're asked to find the LCM of x cubed minus 16x, x squared plus x minus 20, and x squared plus 5x. So I'm going to start with the first one. I can factor out an x, and I get x squared minus 16. And I notice that this is still factorable because I have a difference of squares. So this is x times x plus 4 and x minus 4. This is what I mean by factor completely. I can't just leave it in the x squared minus 16. I have to continue going until I can factor no more. In my trinomial, I have x squared plus x minus 20. I'm looking for two numbers that multiply to 1 times negative 20, so negative 20, and then add to positive 1. So that's going to be x plus 5 and x minus 4. And then finally, I have a GCF of x here, and I have an x plus 5. Now that I've factored everything, I'm going to list any common factors. So anything that's shared. I see that an x has been shared in my first and my third one. I see that, or actually I'm going to cross it off here. I see that an x minus 4 is shared between my first and my second, so I'm going to write that down. I see an x plus 5 in my second and third. And then I don't see any more common factors, but I do have this x plus 4 that hasn't been checked off yet, so I got to list that too. So my least common multiple is going to be the product of all 4 of these factors. Let's summarize. When we find the least common multiple of polynomials, it's useful for adding and subtracting rational expressions with different denominators and solving rational equations. It's a similar process to finding the LCM of numbers. We factor each polynomial, and then we multiply all our factors. First, we start with the common ones, and then any that are left over.